So first we want to know how to find out the differentials of the function. So for this first example, w is equal to x to the second power times sine of 2x. So what we can do is we can look at this as, right, w as a function of x. So therefore, the differentials of this w, that will be equal to the functions evaluating at x times with dx. Okay. So now what's going to happen is when we follow that, this will become dw, that is equal to taking derivative of this product, which is going to be 2x times with sine of 2x, plus now taking derivative of the second factor, which I need to use the quotient chain rule. Derivative of sine is cosine of 2x times with derivative of inside, which is derivative of 2x, is 2. And then times with dx. Simplifying a little bit, that will become dw, differential of w, is equal to 2x sine 2x plus 2x squared cosine 2x, and then times with dx. So this is basically the differential of the function. For the second problem, we're going to be looking at y is equal to square root of z plus 1 over z. So I'm going to look at y as a function of z. So my differentials dy, right, will be equal to f prime of z times with dz. So now taking derivatives, so differential of y, that will be equal to derivative of the f function, which is this part right here. So that will be using the chain rule, bring down 1/2 times with z plus 1 over z of negative 1/2. Now, because of the chain rule, now I have to take the derivative inside, which is going to become, using the quotient rule, derivative of the numerator is 1 plus 0 times z minus z plus 1 times the denominator, which will give me 1, and all over z squared. And then don't forget, we need to multiply everything by dz. Simplifying this, that will give me dy, differential of y, is equal to 1/2 times with changing this into positive exponent by reciprocating the base, which is z over z plus 1 to the 1/2 power, and times with simplifying the top part right here, z minus z plus 1, so which will be 1 over z squared times with dz. So this is my differential of the function. Any questions before I move any further on this, finding out the differentials?
The recording has stopped.
Are we all okay with this? Now don't hesitate to stop me and ask me questions, okay? Even though I'm recording and then stopping recording. It doesn't matter. Because the important thing is that you don't want to wait until I finish it and then forget what you need to ask.
So finding the differential is kind of like finding the derivative, except it's times the...
It has a specific formula right here, right? Because if you're finding the derivatives, we're going to be talking about derivative of a function with respect to something, and that symbol is going to be like, something like this, dy over dx or something like that. That's the derivative symbols, right? But when we talk about differentials, it's basically talking about what? This is the slope of a tangent line, so we can think about, giving a value on each separate part. That's what it basically means.
Okay.
Okay? Because think about it, dy over dx, that is the slope of a tangent line, right? Right? F prime, or this is the slope of the tangent line. So what is the slope of tangent line? Is the ratio of what? The change in y value over change in x value on the tangent line. So therefore, now we are trying to interpret this dy over dx, dy as a change in y value, and then dx as change in x value on the tangent line. So therefore, because of these two different values, I can look at it as a ratio, and I can rewrite it as what? This differential
Okay.
equation format. Follow?
Yeah.
Before, we only look at this symbol as what? One single symbol. We don't know how to separate it out. Now we know the meanings of each part and how to interpret it so that we can separate it out.
Okay.
Right? So basically, like, we know that this is the value and this is the value that will help me to get it.